Today we're going to talk about X-linked recessive traits. But before we do that, let's go ahead and take a look at this particular pedigree. Now a circle denotes a female and a square denotes a male. And these two individuals had 3 kids, 1, 2, and 3. They had a daughter, a son, and a daughter. Any place there is a shaded individual. That means that that individual is affected. They have the trait of interest. Now it's important, they are affected with an A. They are not infected. Infected implies a germ, and that's not a germ that we're talking about here. So they are affected. This female married this male, and then they had 2 kids. They had 2 males, both are affected. Now the first thing I want to do here is go ahead and write down my generations. The first generation is going to be the topmost. They're the oldest. So generation 1, 2, and generation 3. Now I want to go ahead and label each individual with an Arabic numeral. So I'm going to leave a little space for the genotype here. So I'm going to call this individual 1, 2, 1, 2, 3, 4, 1, 2. Now if I wanted to talk about this individual right here, I would refer to them as 3-1. So they would be 3-1. What if I wanted to refer to this individual here? 2, Roman numeral 2-3, and so on. Now, the next thing I want to do is determine the mode of transmission. How is this trait inherited? Now, think about the flow diagram I gave you earlier. The first thing we want to figure out is this trait dominant or is it recessive? So, do all affected individuals have an affected parent? So let's look at some affected individuals. Do they have an affected parent? No. All we have to do is find one exception, and then by default, it's going to be a recessive condition. So this is a recessive condition. Now once I determine that, then I go on to the next set of criteria. And in this case, does it mostly affect males, or is it pretty much even, 50-50, in and around there? You can see 3 males are affected, no females. So this is going to be an X-linked condition. It's going to be X-linked recessive. So I'm going to go ahead and write that down. X-linked recessive. Now, whenever a condition is X-linked, the first thing I like to do is put a Y as the second letter for all males. So let's go ahead and do that. There's a Y, Y, and Y. The reason I do that is because males have their second chromosome is a Y chromosome. They only have one X chromosome, where females have 2. Now sometimes, some people just prefer to leave that second letter blank. But I don't like to do that, because then I have a hard time remembering, did I totally complete that individual's genotype or didn't I? So I like to put a second letter there. That way I know I've dealt with that individual. Now the next thing I want to do is, this is a recessive condition. That means all affected individuals must have 2 lowercase a's if they're a female and 1 lowercase a if they're a male. Because again, males only have one X chromosome. So let's go ahead and write that down. All affected individuals are going to have lowercase a's. All unaffected individuals must have at least 1 uppercase A, because remember, the uppercase letter is dominant. It will match the effects of the second letter. Now that's our given information. You should be able to figure that out relatively straightforward. Now comes time for the detective work. We have to figure out what's the second letter, second letter, second letter. So let's go ahead and do that. Doesn't matter where we begin. So let's go ahead and we'll start here. So we're going to take a look at this person's parents. Now here's a capital A. Now this is a daughter. So dad had a daughter. Dad cannot donate a Y to his daughter. So dad must have given a capital A to his daughter. So there it is. And mom could either give a capital A or she could give the other letter, which we don't know what it is yet. So I can't really figure this one out just yet. I'll come back to that. Maybe I can, maybe I can't later on. I don't know. Let's go ahead and try to figure this one out here. So here's her son. Now mom cannot give a Y to her son because she doesn't have a Y to give. Only a male has a Y. So this capital Y came from dad. That means this lowercase a had to come from mom because half of the genes come from mom and the other half come from dad. So this is going to be a lowercase a there. Now can I figure this out? I still can't figure out the second letter for sure. So when that happens, I'm going to go ahead and I'm going to put a dash there. And the dash indicates I don't know what that second letter is for sure. Could be a capital A, could be a lowercase. I don't know. Maybe when this individual has some kids, we could figure it out then. But right now, don't know for sure. Let's go ahead and take a look at this individual right here. Here's the kids. The Y, because these are males, the Y had to come from dad. In both cases, the Y has to come from dad. That means this second letter here, this lowercase a, had to come from mom. So we'll go ahead and fill that in. And let's go ahead and check. Make sure that every single person has two letters. Two letters, two, 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 two. So I've handled everything here. And that's it for X-linked recessive.